And joining me for this fireside chat is Tanushree Sharma. Tanushree is a product manager at Cloudflare, building Workers, Cloudflare's serverless compute offering. Her role focuses on unlocking new use cases for workers and solving developer pain points, with an emphasis on building a great developer experience and ensuring that performance and reliability scales. Outside of work, you can find her doing yoga, trying to walk her cat, the keyword there being trying, or outside scouring green spaces in New York. Please welcome Tanushree. Yes, really excited for this. And real quick before we dive in, for all of you in the audience, because we're kind of compressing the time we would usually have for presentation and Q&A, if you have questions, just keep the conversation going in chat. I'll check every couple minutes and try to filter those into our conversation. As we were talking earlier, Tanushree, we were saying, to set this up, probably looking at a quick history lesson. So can you start with how did serverless computing emerge? How has it changed the life for developers?
Yeah, that's a great question. I actually love diving into the history a little bit before getting into some of the details of serverless and all of the fun things that people are building, because it really helps you appreciate how far the industry has come in not a lot of time over the last maybe like 2-3 decades or so. It also helps you appreciate how much more accessible software development is now when compared to a couple decades ago. So let me walk you through kind of some of the history and walk folks that are watching through as well. And it's kind of crazy when you kind of think about it linearly, how things have changed and how there's been a huge shift in how applications are both developed and deployed. I think the TLDR and the thing to get from this, though, is that it really boils down to each step of the way. There's been more and more abstractions from managing the underlying infrastructure, which has led to a focus on just building and deploying the applications themselves. So less focus on infra, more focus on development, which is the fun part, which is what we're all here to do, right? So I think where this really started is kind of late 90s, early 2000s, where, in order to spin up a website, you would have to buy physical servers to host content on, or maybe rent some dedicated servers that lived in a shared space. But then going from just a server to a web application was not simple at all. So as a developer, you'd have to think about things like the specific hardware specs that you need for your use case. Things like networking, bandwidth, interconnectivity, like all of those things had to work in order for to provide a good end experience for users. Things like how do you scale if there's sudden growth, or maybe the answer is you don't scale at all because you just have like this fixed amount of space and you just kind of cross your fingers and hope for the best. And also something like, if you're a business that's renting a rack somewhere, you want to be able to understand, like, what is the physical security of this building, of this place that I am renting? How do I make sure that no one is going in and tampering with things? So those are things these days that as a developer doesn't even cross your mind. But there was so much overhead involved when things first started out. And then from there, we kind of shifted into cloud computing and more of like the infrastructure as a service mindset. Which is very similar to buying your own servers, except you're renting virtual machines from some sort of managed provider that manages the hardware, rather than like the physical hardware themselves. So easier to get something spun up, less overhead. You're not interacting with that hardware directly, but you're still managing the infrastructure. You're still taking care of scaling and any of the operational tasks that I mentioned just before. And it's kind of funny when you think of like, I just want to build a website back then, and what an app developer had to think about and what they had to do. You need to be a developer, but you also need to be a network engineer. You know, be able to figure out all of the configuration, all of the DNS config. How do I make things work? How do I make sure that all the plumbing goes through? And you also need to know your stuff when it came to hardware. There's just so much extra thing to think about. You need to think about everything that sits below the application layer. So either like you have to go become a pro or figure out how to hack things together in this way, or you need a team of people to just build a simple web application, which when you think about that today, you're like, whoa, like things are so easy. I can just do this myself. I can have something up and running in less than 10 minutes. Like Sean, you're in Netlify, and your DX is super easy, super quick, and don't need a team of people. You just need somebody with an idea, somebody with some designs in their head to then go like put that on paper or put that in their keyboard and kind of make it happen. So kind of cool to kind of see how some of the skills that are needed have changed throughout the years there. And then I would say
100%.
Yeah, go for it.
So yeah, I spent a number of years before Netlify even existed working for a small agency, and we were just mostly, I mean, we built some complex business applications, but for the most part, we were building marketing websites of various sizes. And it still was like, well, but we kind of want this go-to tool set for everything that we're building. And so everything was Ruby on Rails, which meant you had this content that it was edited, maybe once a week, or if they have an active blog, then maybe once a day or so. But that every time somebody was visiting the site, we were running the server, we were hitting the database. And so we needed, as a small team of people, we needed folks who were experts in front-end engineering, but also we needed to know how to manage all of that infrastructure, and there was the risk of everything going down. So yeah, when we got into this era of having these tools in place to be able to offload the management of that infrastructure to some of these providers like Netlify or Cloudflare, that then it's like overnight, that's one less thing that we have to worry about, and we can have some more confidence that that website is going to be up. We can spend our time more on the business logic, and I feel like that really changed things in terms of my quality of life as a developer building those everyday websites.
Yeah, I bet you also felt the pain not only in kind of the development flow as well, but if somebody wants their blog updated, once a day, actually, like, how do you deploy that out when you're managing your infrastructure, and how do you make sure that things are scalable and that you're not adding like extra complexity in there that's going to have more overhead? Do you want to touch on that a little bit too? Was that challenging?
Yes, I mean we generally wouldn't build and deploy unless we had actually changed code, but the complexity got shifted to, for the most part, especially with those content heavy sites, that it was we were saying, hey, do we really need to be hitting this database every time? And so what the complexity was largely shifted to caching logic, and that was really all on us to determine when to set that cache and when to break it. And those are the things that I haven't even thought about that kind of stuff in years, because it's just handled for me today.
Yep, totally. I also want to touch on kind of the next thing that stemmed from the shift into cloud computing, was from like infrastructure as a service then to more of like a platform as a service technology. So this is like another layer of abstraction on top of infrastructure as a service. So things like servers, storage, networking, operating systems, those are then offloaded into the platform as a service provider. And then that provided developers benefits like, if you're not managing infrastructure directly, you don't need to worry about things like software updates or patching. Those scary TVs that come in that you need to patch overnight. Those are things that the platform provider would then handle. So things like scaling, for the most part, there'd be some built-in scalability features. If you're hosting an e-commerce website and you need to handle a Black Friday Black Friday sale, you don't need your team kind of working days and nights up to Black Friday to make sure things scale. And I think the other cool thing that came from this platform as a service model was some of the billing really changed here, right? Like, it was less of an upfront pay for exactly what you're going to use, predict what the usage is going to look like. It was less of that and more of pay for what you actually use billing, which made development so much more accessible to more businesses, to more people, especially kind of things that weren't big corporations that had the investment ready to spend. I will say definitely.
I think
with
it was interesting because if like thinking of that change that yeah, it was like if you had this predetermined amount of computing power on the box that you were renting or using or whatever it was, that you had to scale up. Like, well, we got to shut everything down and go down, and then we got to recommission a new server, or whatever, however service, whatever the process was for the service that you were using. And yeah, and it's interesting because that like the shift to meter based billing it's kind of I've found it to be this double-edged sword depending on the type of project that I'm approaching, because for most of them you're like, okay, well, the usage is going to be so small that the cost is going to be nothing or nominal. But I'm curious on that point. How do you think about what's your approach to being able to predict the cost for higher scale or more complex applications?
Yeah, that's a good question. So I think that we typically see like two varieties of usage patterns. Either maybe you have a blog post and it gets fairly consistent traffic, and then you don't need to think about really like what is the spikiness happening here. It's just more of like, how many users do I expect to see a day, and then I can kind of manage costs both from a if you're looking at serverless or if you're looking at other technology standpoint. That's obviously the more simple case there. And then I think generally more broadly, what we see, especially with like e-commerce websites or things that are seasonal, you see that spikiness in traffic, and as developers, you need to be able to handle that load and also handle predictability and costs. I talk to like enterprise customers all day on about workers, and they're like, "How do I know how much like requests or CPU time my worker is going to be using to be able to predict my costs?" And I think it generally tends to be like run a POC at small scale, figure out like actually how much compute does your application need, and then try and scale that up and predict, and like have some margin of error built. No, it's not going to be perfect, that sort of thing. I also do know a lot of platforms have like limits baked into the platform as well. So just in case you ship code that accidentally has some sort of bug, you don't get charged for runaway CPU time or duration for your functions. So taking advantage of that and making sure you have guardrails in place, because that is a scary side of serverless, is that if something goes wrong, you're not managing it. It's not like your server goes down. It's actually you're just racking up fees. So yeah, I think those are the approaches I would take generally, is like ballpark estimates and then making sure you have guardrails as well.
For sure, because I mean, on at that large scale, it's like there are types of events or situations that would spike the cost that could be really good. Like your site went extra viral today, and you're like, I'm happy to pay that money because it means more sales for me. But then you end up with, there's the other side of it, the DDoS attacks and things like that, where it's like you want that visibility and those hard limits in place so that you can protect against that unnecessary and unexpected spending.
Yeah, and I also think things like alerts. So nothing, you don't actually take an action on behalf of your code running, but just like tell me when something crosses this threshold, because like, maybe something's wrong and I need to go check on it. Those are also really helpful signals to configure as well. It's more of like a sanity check rather than taking action on something that actually might be like legitimate traffic.
For sure, definitely.
Yeah, the other thing I'll add around platform as a service and spikiness and handling scaling is, I think with these types of platforms, you still need to answer questions like, how does my compute talk to my database, and what do I need to set up so that my application doesn't crash at different levels of scale? So those are some problems that still really haven't been solved with platforms as a service providers and technologies. If I think back to actually like the first time I deployed an application, Heroku has a very soft spot in my heart. It was one of my first software projects was deploying a Flask app to Heroku. And it was really cool and satisfying to see, like, you hit the button, you see the build logs, like waiting for it to go, and then it's successful. And then you can then go kind of hit it and it's accessible. So Heroku is an example there. Like Google App Engine was one of the big first products that made PaaS popular. Do you have any kind of similar stories or sentiments to share, like your first time deploying something where you didn't have to worry about
Yes.
infra?
Yeah, there were. I very clearly remember two key points in my career, and the first one was Heroku. We were using different services over the years for primarily Ruby on Rails applications, and mostly DigitalOcean as the service provider or something similar. And to build and deploy, it wasn't just handled by DigitalOcean. It was also, I recall, needing additional tooling that would do all of the compiling, building, running.
Mm-hmm.
We'd run the tests and everything, and then push it up. And so Heroku was the first one where, still running Ruby applications, I was like, you mean I can just git push and then it's going to do everything for me? This is amazing. This is amazing.
Magical.
Um, and then, but there was still some those were still in my Ruby days. And so there was still a bit of, you have this running thing and it could go down for whatever reason. It's it's running all the time. And so it was, I mean, years and years before I worked for Netlify, Netlify was my other milestone where I was like, oh, I can do the git push thing again, and then it deploys, but also it deploys static files for me. And now I can just kind of like walk away and nobody's going to wake me up in the middle of the night. This is amazing.
Yep. Yeah, it's kind of crazy. You have those like magical moments where like this technology is so cool. It's a game changer. And I don't know, I felt that with like the first time I deployed a worker as well. I was just like, you just like hit a couple buttons on the dashboard, give it a URL, and that's it. And then you have a functioning like hello world type application. It's kind of really cool to see some of that evolution. The last thing I'll touch on
Yeah, I was
as we're
curious.
talking about.
Oh, go
Yeah.
ahead. Go ahead.
No, go for it.
I was curious for you to talk a little bit about workers in particular, because that's one area that I haven't played with them much. I hear a lot about Cloudflare workers, but I haven't dug in. I'm just curious, could you give like just like quick intro to them?
Yeah, totally. So Cloudflare workers run on Cloudflare's network, and we run a distributed network. Cloudflare's bread and butter was really our CDN, caching services, and security came on top of that. And when you're running a CDN, you want to be distributed. You want to be as close to your end users, or we tend to call them eyeballs. You want to be close to your eyeballs as possible to be able to improve latency. And so we had this kind of huge network, and we had a lot of compute that was available. And so the inception of workers kind of came about. It started off as a little bit of like more around like CDN augmentation. How do I make the WAF programmable? How do I'm a customer, and based on the example use case here, I'm a customer, and based on the location of my users, I want to be able to serve them like slightly a slight variation of what my WAF rules are configured as. And so as a company, we found it hard to like be able to program all of this into the product itself. And that was kind of the inception of workers, where it started off as like a really lightweight, upload some JavaScript that has a little bit of logic, and then it impacts some of our kind of security focused systems. But from there, once you can do that, you're like, what is actually stopping me from hosting on our network itself? We have all of this compute. We're distributed. We're located close to users. Why can't people just actually like build applications, build full stack applications, build front end applications on workers, or the kind of front end counterpart of workers? What's actually closest to Netlify is our pages offering. So that's kind of a little bit about how it came about. I think when you think about serverless platforms, there's kind of this big bucket of serverless, but it gets a little bit nuanced as you get into it. Where when you compare us to a provider like AWS Lambda, Lambda is kind of an abstraction on top of containers, whereas Cloudflare workers run on V8 engine, which is the same thing. If you're using Chrome browser to watch this today, it's the same thing that Chrome browsers use behind the scenes. And so some of the specific architecture decisions on the different platforms have impacted the use cases that they're good for, or things that, a little bit harder on the platform that you need to work around. So that's kind of general high level on workers.
Yes. Okay, great. Thank you. I feel like that really sets the context for yeah, for some of these other topics that we'll get into for sure. So yeah, sorry, and I cut you off, so I'll hand it back to you.
Yeah, I was just gonna say that the last thing to touch on is like the big thing with serverless was when you go from like platform as a service to serverless was just like you just upload some code. That's it. You upload some code. You define a trigger for that code, whether it's you know, a URL that you want your function to run at or your website to run on, or you have a cron job defined that runs something every 10 minutes. Like those are the kind of the only big pieces that you need to supply, and then from there you just hit a button, and then it's all on the hosting provider to take care of all of the rest of the things underneath. So that's kind of where some of the magic comes from, and why so many people are so attracted to serverless.
For sure, definitely. And so we've and what have you seen since those early days? Yeah, and what have you seen since yeah, that serverless foundation has been established? What has changed since then?
Yeah, I think I touched on this just earlier, but I think some of the use cases of serverless really started off small. So started off like serverless is kind of more of the glue that handles some communication between systems. So let's say you wanted to, you know, do some data transformation before a call from one system went to the other system. I think that's kind of where it started off. People were like, oh, interesting. Like maybe we could use serverless for this type of event-driven task. That I've seen, like, I think it also started off as very like, I just want to prototype something quick, and I can use a serverless environment because it's so low overhead and you don't need the infrastructure, and you can just like try something out without having to sink a lot of time or cost into it, which is actually like the big benefit of serverless. And it started off as like kind of a toy of like, oh, let's just see if we can do something, and then people started to realize the power as they got faster and faster. I think now it's at a point where like you can deploy full stack applications on Netlify or on Cloudflare pages, or kind of there's tons of companies in this space. You can you know, create APIs on serverless platforms, things like real-time coordination as well. Yeah, similar to other providers in this space, Cloudflare has a lot of compute, storage, video offerings that really supplement all of this. So it's not just a, you know, serverless app. It's all of these things that kind of make it stateful and kind of add some of the extra things that you can do in an application as well.
For sure. I've felt something very similar, and I see it seemed like in those early days we had these monolithic, always on applications, and then there was the movement was very much in the opposite direction to say, hey, there's some sites where you could pre-render everything and you don't need any moving pieces. But then the reality was that most websites out there are somewhere in the middle, that they could take advantage of pre-rendering in some form, but that then you need some dynamic bits. It's just really hard to get around. And it seemed like in those early days, you could write your own serverless functions, but yeah, as your application grew in complexity, that became a lot to manage. And so we saw these services pop up for various different tasks. But what I've seen in recent history is now it's become so easy to work with serverless functions that you still have the monolithic approach, you still have the fully static approach, but there's just so many different approaches that you can take that sit somewhere in between those things, that you've got this ultimate flexibility to design your architecture however it's going to best suit you. And on one hand, there's a ton of power in that. But one of the other challenges that I've seen with that is it becomes a little bit harder to teach about it, or to especially what to recommend someone who's just getting started. You're like, well, you could go this way or this way or this way and have the same website, but running in three different, three different architectures, essentially. And it doesn't necessarily mean one is better than the other. So yeah, that's something I feel like I still haven't figured out. Earlier today, with Phil's presentation, at first he really focused on getting back to simplicity and starting there, and so that's generally the approach I've been taking. But yeah, it's like, well, there's so much power, but with the power becomes the challenge of and the number of options, choosing the one that is right. How have you well, have you seen that evolution as well, and if so, how have you handled it?
Yeah, I think the big benefit with serverless is composability. So you can have kind of a piece that you start very simple and then you add on to it, and then you're like, oh, I want to add maybe a notification system onto my web app. So I can spin up a separate serverless function that then can talk to this one that has the core application logic. So I'd agree with you in like starting simple. Don't try to complicate or over engineer something when you're first starting out. Just kind of focus on the customer use cases, focus on exactly what you're building, build for that, strip away all of the complexity, and then as you're getting more ideas, if you get more fun ideas or more requests from users, then like start baking some of that in and figure out how to do it in a way that I always recommend. Like it's a trade-off between like, oh, I have a serverless function that does everything. Like I have like teeny microservices that, and I have 100 of them, versus like maybe you have 10 microservices that kind of like handle chunks of logic. So being able to kind of balance some of that as well and figure out what are your development practices, kind of what services make sense to couple together versus what makes sense to split out, because of both from like a development standpoint and a risk standpoint when you're deploying. I think some of those things factor into it as well, but I fully agree in just like starting simple. I think the benefit of serverless is that the sunk cost is low, and so you can make changes and re-architect as needed, especially when compared to something like a monolithic application.
That's a great point, that the sunk cost is low, for sure, for sure. Much easier to get into, build a proof of concept. But on that note, what are some of the challenges that you've seen, even as far as we've progressed in recent history?
Yeah, I think three of like broad challenges that I tend to hear from customers are along the lines of like vendor lock-in, around standards as well with serverless. And then the last thing that comes up quite a bit is observability. So I'll touch on each of these a little bit. The vendor lock-in part is kind of interesting. It's a real kind of trade-off, because as a developer, you're excited to take advantage of maybe primitives that the provider that you're using offers. But then you have the trade-off between like portability between different providers, or maybe to an on-prem environment, and taking advantage of some of those building blocks that might be unique to that specific provider. This isn't a concern when you're running something in a container, because they're self-contained portable unit that you can typically run, build once, run anywhere, that sort of mindset. But you're kind of like taking a bet on a provider, and balancing concerns about portability there. So I don't have a great answer to this question other than like, what's your use case, kind of what are you building, and what are you willing to take bets on, versus what makes sense to actually like step back and kind of hedge between platforms. But I will say, like, there are some really cool primitives that lots of providers have. One I can provide for Cloudflare is we have a product called Durable Objects. That's a concept that's unique to Cloudflare as far as I know. They're one of our compute products, and what they do is a durable object is like a strongly consistent data storage with compute attached on top of it. So we have lots of customers that are building really cool like collaborative editing tools, interactive chat tools, like building for real-time environments, and durable objects come in really handy there, just to abstract away from some of the actual like coordination layer that we kind of take that complexity on for you. But if you're a user and you're concerned about vendor lock-in, it's a barrier to being able to use some of those, is thinking about hedging or thinking about other providers that you might want to turn to. So yeah, balance and a trade-off, kind of depending on what people are building. The other one I'll mention is open standards. So it relates to the first point, but it's a slightly different angle on it. It's more around standards on the actual like JavaScript runtime in itself. There's a group called WinterCG, which both Cloudflare, Netlify, a suite of other providers are part of, that focus on helping improve interoperability and create standards for web APIs. So excited to be part of that. And I think that's kind of the right direction that the industry is heading in, is is some more standardization there. And then the last thing, I'm sure that you've come across this as a dev as well, is observability and debugging becomes tough with serverless. You can't SSH into a server to view the logs, so you can't access the file system of a VM directly. I think that some of the challenges comes from can be a black box unless the service provider is giving our developers the tools that they need for visibility. So I think there's been a lot of improvement over the last few years on this, and I know personally for Cloudflare workers that we have a lot of way to go from there. But it's something that's a little bit hard and kind of a little bit scary too as a developer.
100%, yes. And on that last point, also where Netlify is putting a ton of energy right now is just more visibility, more insight into what is happening, because there's just more work being done on that side of the platform than in the past. And and I wanted to mention the lock-in piece too, because that's always been a really interesting conversation to me. I spent about a decade in the agency but before moving over to the product space, and in that world, that was definitely concerning to me, especially when shifting into the Jamstack JavaScript world and kind of leaving Ruby behind. There was so much changing all the time, and it was like, well, this framework is cool to use, and it seems like it works really well today, but what's it going to be next week? I don't know. And it has settled maybe a little, but even over year over year or so, there might be another one that pops up that starts to get some attention for one reason or another. And so as an individual, if you look at me being that person who's building something on behalf of someone else, I actually, the way that I've talked to my previous clients about it was more like, I'd kind of rather be locked into the platform than the framework or than the various little tools that I'm using that are closer to me, because those are the things that seem like they are changing more rapidly. But part of that conversation is, well, you have to get locked in somewhere to some extent. We have to make decisions. We're just trying to make the best decisions and make the appropriate predictions of where are we most likely to migrate first based on the conditions I know today. And now if I put my Netlify hat on for a moment, and I think that the responsible thing that we can do, even if we were to say, okay, the place you're going to get locked into the most is the platform, that then I think it's up to the platform to also say, recognize where that lock-in might happen, and also then make sure we're doing what we should be doing to help you decide if we're the right choice, and if we are the right choice, that it is as minimally painful as possible if it comes time for you to switch. And I don't know, it's a hard place to land, but I feel like it's such an interesting part of the conversation. It's like, where are you choosing to get locked in? Because it's somewhere, and to what extent are you doing that?
Yep. Yeah, and as you said before, there's 100 different ways to build something. That means that kind of depending on the framework you choose, depending on the storage you choose, you can really go one of many ways, which is a good thing, because you have the ability to move around. And let's say a specific framework isn't working well and isn't scaling well for the type of application you're building anymore, you can switch. But also, it makes it hard to kind of keep up and also make sure like what's the right thing to place about on here.
Sure, for sure. All right, well, we have just a few minutes left. I'm curious to get your take on where you see serverless technology going in the next couple of years, and it's hard to ask that question without also hinting at, and it probably has something to do with AI in some way, right?
Yep, that's the big buzzword in every industry, but I would say especially so as a developer. It's such a great time to be a developer and get to play around with interesting tools. I think the big thing that I always think about when we think about the future of software development and serverless is the goal of any company, big or small, anyone that's building any projects is like time and speed are your biggest assets, right? The faster that you can build, the faster you can go to market, the faster you can get an idea that's in your head on the screen. the more fulfilling it is, the more rewarding it is. Like that's what people are striving for. Um, and so I'm going to give some answers, but I'm heavily biased with this question, just based on Cloudflare's approach. And then I'm curious to hear about kind of how things work at Netlify as well. But I think a couple things I'm really excited about. We've been playing around a lot with AI code generation. That's going to be a really fun space to be in, where like you have an idea in your head and you can describe it really well, and then let the model kind of actually deal with all the complexities, all the nitty-gritty pieces, and like think about kind of how fast that you can move in that world. So excited to see more of those types of applications being built to enable developers to do that, or even at least get some templates started so that you have something to start on, and then you build in your customization, or you build in all the fun wacky things that you want into that. So excited about that piece. We also launched an AI inferencing product at Cloudflare a couple months ago. It's called Workers AI. It's essentially like serverless AI is the way we like to describe it. So you're not renting out your own GPUs for inference, but relying on us as a managed provider. Lots of other companies have, cloud providers have similar concepts as well. So that's been cool. And we've been seeing some really interesting applications spun up from there. One example I can give as of recently is we had an intern that just joined the team that built an application that you put in a web page. It goes, it scrapes the URL, gets the markdown, and then you can give it a prompt, like give me a summary of this page, or ask me some questions about, test me, quiz me on this website. And so they just kind of went and built that out, and it also uses Workers AI, and a couple other products in there. So really cool to see some of those use cases coming out. The other thing I'll touch on quickly is I think the general approach of Cloudflare in terms of thinking about the future and what to build has been really minimizing complexities and challenges that developers have to face that don't contribute directly to business value. It's kind of like, how do we make building an application dead simple, and what are the primitives we can give you for that? And also, where can we as a platform be opinionated, where maybe the network is making the decisions rather than a human making a decision? Things like, where should this function be placed is something that we think that we can actually do a better job at than you as a person can, because we have a ton of data. So those are things that we're trying to, that we're working on making better, and also connectivity from a serverless function out to the rest of the world. So how do you connect to databases in a safe and performant way are things that we're thinking a lot about, and kind of focusing our product muscles on.
Yes, that's great. And honestly, as you were talking, I was thinking of like, okay, well, yeah, where are we going? And there's so many parallels there, which means that the industry is definitely moving in a direction which is really great. We're also exploring generative AI options, also looking at AI from the more of also an aid. So not always something that's necessarily going to give you content or code that you're going to use in production. Like definitely still exploring that, but also one of the features we released recently was a button next to your build log if your build fails, and says, why does it fail? And it reads the log and tries to very quickly tell you what went wrong and this is what you should do. And that immediately, because that's like when a build fails, that can be a really stressful part of the flow for a developer. You're like, back to the black box thing. If you don't have the right logs, it's hard to know exactly what went wrong. And so that's been a really interesting project to pursue. And then the other point, also similar to platform primitives, is that we've known for years that the framework of choice is going to change. It's going to ebb and flow. Things are going to come in and out of style or preference, and not necessarily move in any predictable way. But if we look at the last few years, when a new framework arrives on the scene, it often brings some new idea or some new pattern with it, which is particularly attractive to developers for one reason or another. And so what I'm seeing happen on the platform level is being able to kind of even that out across all of the frameworks in the ecosystem today, so that if framework A lands on the scene tomorrow and all of a sudden devs are all over it and it brings some new pattern, that we can then say, okay, great. How can we build a primitive that can transform that pattern into something that works on our platform? But then if that pattern isn't also supported in framework B over here, there's still a method for someone working in that framework to be able to get that type of functionality with on top of, or with the platform. They're just, the code that they write is going to look a little bit different. And so for some of the more powerful or maybe like more feature rich frameworks out there today, that developers can feel like they have all the features of that framework at their disposal, and they just work when they deploy them. But then framework that might not have as many of those features available, you can still make all those things work. You're just going to do it in a little bit of a different way.
Very cool.
Yes. Well, Tanushree, thank you very much. This was a really, really fun session for me. Appreciate your time and your thoughts.
This is great. Thank you for having me. And I hope the audience at least learned a thing or two. And if nothing, had a good time kind of chatting through this with you, and also getting different industry perspectives on how you see things versus kind of what things are like at Cloudflare. So yeah, thank you so much for having me on this.
Absolutely, 100%. Feel the same way.